Hi everyone, and welcome to the last in the series of Ask the Experts. Today's topic will cover maximum protection for your software, basically the new technology behind the Sentinel Envelope. Our presenter today, as always, is Mark Horvath, one of our experts and a sales engineer with SafeNet. For those of you who are unfamiliar with the Ask the Experts webcasts, basically these webcasts were designed to help you stay up to date on key product changes, issues, and solutions while providing education on, and training on the latest technology developments. My name is Asaf Regev, and I will be your moderator for today's session. So today's session, let's kind of recap and kind of give you a bit of an update or a preview on what's sort of to come in Mark's presentation. So what we'll be covering today is basically the technology behind the Sentinel Envelope. And kind of before we start talking about the Sentinel Envelope, basically for those of you who are unfamiliar with the whole concept. So an envelope is basically an automatic file wrapper that provides intellectual property protection against software reverse engineering through file encryption, code obfuscation, and system-level anti-debugging, basically ensuring that your algorithms, trade secrets, and professional know-how is secured against hackers, reverse engineering, tampering, and/or automated attacks. So before we get started, I'd like to remind you, excuse me, that you can submit questions at any time using the questions button. Just click on that button on your screen, and we will sort of answer all of these questions at the end of the webcast during the Q&A session. So without further delay, I'd like to hand this over to Mark. Are we ready to go, Mark?
Sure, we are. You had this other slide about joining the conversation on Twitter. You want to talk about that?
Yeah. So basically, for those of you or social media users online, we encourage you kind of to join the conversation on Twitter and also with hashtag AskSafeNet, giving you some idea on software monetization or our software monetization solutions, best practices, and sort of best practices to follow. Additionally, there's the Licensing Live, which basically provides you some announcements on awards, releases, and some really cool and interesting stuff that a lot of our SEs or sales engineers and top-level executives kind of share with thought leadership. So some neat stuff. So let's get started, Mark.
Okay, thanks, Asaf.
Yep.
Welcome, everyone, to our latest Ask the Experts webinar. As Asaf explained, in the past we've had a number of technical topics, such as we discussed hybrid cloud technologies and white box cryptography. And so today we'll continue on with a closer look at the technical aspects of software rights management. Today our focus will be on software packers, specifically how they're used in our Sentinel Envelope anti-software piracy product. Now, let me first of all say that for those of you in the audience that who joined us thinking that the talk is about some professional football team in Green Bay, because I'm talking about Packers, it's not. And having grown up as a Chicago Bears fan, I say take your cheese and bratwurst and please leave now. Thank you. But anyway, all joking aside, let's review what we're going to cover in today's session. First of all, we'll discuss how packing works while going through more details about the various file formats, primarily concentrating on the Windows Portable Executable or PE format. And note that even though we're going to do this, we support other formats such as Linux, ELF, and the Mac-O format as well. Next, we'll discuss the reverse process, that is unpacking. The goals of unpacking and the various tools and techniques that are used. We'll continue and review Sentinel's LDK's third generation envelope and the new features it has to offer. And finally, I'll have a pseudo demo which will illustrate some of the anti-piracy capabilities of Envelope. Due to the BrightTalk interface, I'm unable to really show you a live demo but instead I'll have screenshots that should work as an effective substitute so you can see what's going on. So let's jump right into the presentation. So as discussed, let's start out with the whole idea about finding out what packing is. You're likely familiar with the concept of zip files, where an original file is compressed into a fraction of its original size. But packing is also an effective deterrent against software piracy and also intellectual property theft. Another thing that is not mentioned here in the slide, but we discussed it in context later, packers are often used with malicious intent by malware creators in an effort to thwart detection by antivirus utilities. There's numerous examples of packers in the industry. I mentioned Zip before. There's also what's called the Ultimate Packer for executables, or UPX. And we have tools from SafeNet. We have our code cover tool, and then today what we'll talk about is our envelope tool. So having better understood the purpose of packing, let's now discuss exactly what a packer is. Think of a packer as similar to a Russian Matryoshka doll. That is a doll within a doll within a doll, etc. And apply the same principle to a binary file. Basically, a packer is a tool that modifies an executable and creates a new one, either for the purpose of compression or, in our case, a reverse engineering protection method. And now the packer works in such a manner that it fully adapts its operation based upon the target operating system and its unique file format. And for example, we have the Windows portable executable format that I mentioned, the Mac O format, Linux's executable and linking format, and we also have intermediate bytecode such as for .NET and Java. And what's important to mention here is that good packers work for both 32 and 64-bit architectures. So diving a little deeper now, let's go over the structure of a PE file, a Windows portable executable file. The first part is the PE header. Its main purpose is to identify the PE file structure. Note that 32-bit files are typically referred to as PE32, and 64-bit files are referred to as PE32+. It's important to note that PE files are not strictly executables or .exe files, but they also could be object code, dynamic libraries or DLLs, font files, and other types of files as well. Next in the PE file is the code section. This includes the read-only machine code. It's converted from high-level languages using a compiler, linker, or assembler, and such that once the application is launched, this code section is what's executed by the CPU. We also have the data section. This is where all data such as variables and strings reside. Now, the import address table, or the IAT, is a very important aspect of the PE file structure. This section references all the functions which are used and reside outside of the executable. For instance, if I write a Windows program that displays a message to the screen, I'll use a function called message box. And this function is part of Windows DLLs, and it resides outside of my executable. And therefore, it will be listed in the import table. Now, as part of the envelope packing process, we actually protect the list of functions that are used by the table so that hackers cannot understand or extract their exact location from memory. And as I step in the demo, we'll actually see this. And then lastly, a PE file may contain a resources section. This includes such things as like icons and images and even version information and other GUI-related type information. So now what's the actual purpose and process of packing? So the process of packing, as the name suggests, packs or compresses a program executable. The process can add one or more sections to the original executable in addition to attaching a loader. In this case, we call this the envelope runtime, which goes ahead and unpacks the program before resuming normal execution at the file's original entry point. Packers can also update or remove the import address table as an anti-piracy measure. We'll go into more details about what the IAT is, or the import address table, in later slides. Now note on the image on this slide, it represents the original or unpacked file with its original entry point and PE header. Now if we protect our executable by running it through envelope, we'll have a reconfigured file. Included in this new file is the loader. So let's discuss the role of the loader. I know I mentioned it before, and I mentioned it and I described it as our envelope runtime. In a general sense, the loader is part of the operating system that's responsible for loading the application. Now, in the context of a PE file, the loader grabs the executable, for instance, from disk and places it into memory for execution. Now, in the case of the envelope runtime loader, it also includes the running of real-time tasks such as anti-debugging detection and tracing detection and license management and background checks. And this is where all these are administered within the envelope runtime loader. And so the envelope loader is also responsible for jumping back to the original entry point once the application terminates. Note on this slide, the original application, as the one on the left, we show the PE header and its entry point, as opposed to the packed application on the right, whose original code and data have now been encrypted, and we annotate this by showing the slanted lines. And the new envelope runtime has been added in addition to the new PE header, and this PE header is, of course, different than the original. So another measure of what envelope does is it modifies the entry point. So the entry point refers to the address and memory of the first execution to be executed once the application is launched. The packer, as mentioned before, mentioned in previous slides, it saves the original application's entry point, which is then transferred to the loader, in our case, the envelope runtime. Now again, note the change in the entry point from the original on the left-hand side to the pack file on the right, which now includes the new entry point, which is different from the original one. So in order to make this a little bit more visual, let's look at an example. In this example, we depict the difference between an unpacked or unprotected application on the left-hand side as compared to a packed or protected application on the right. With the protected application, we have a different entry point. So for example, on the left-hand side, the unprotected app, the section.txt contains the original entry point, whereas on the right-hand side, on the protected app, the section.new refers to a new entry point with a jump command to the original entry point saved by the packer. Now, we'll see this in our demonstration. Now that we have covered packers and loaders and know a little bit more about the protection side, let's examine how the reverse process works, that is, unpacking. The main goals of unpacking are to, first of all, remove the packing layer or the protection layer, and then receive an equivalent of the original protected application and or remove code calls to the protection key. Now, these are some of the more common unpacking and analyzing tools available. Many are a staple in the engineer's toolbox and very often are used by specialists such as cybersecurity analysts who want to learn about the intimate details of a binary file. During the demo, I'll utilize, among others, the two at the top, PE view and the IDA disassembler. But there are also that could be used as well. For example, olidebug is a robust debugger for binary code analysis when source isn't available. Imprec is used for import table reconstruction. And Microsoft has a number of tools as well, notably packaged with their sysinternal suite. Now that we know the tools required, what technique is used behind the unpacking process? Now, the unpacking techniques vary, but for the most part, these are the main notable areas. First of all, you want to make an attempt to find the original entry point. This is achieved by slowly tracing the protected application until a jump instruction is found. And this can indicate or hint the behavior of the running application in addition to the state of the stack and its contents. Another option is via smart use of hardware breakpoints or API breakpoints, which again may hint on the use functions and or the APIs that are being used. And lastly, the use of the stack with various push and pop operations can be looked at in an attempt to retrieve the latest operations performed and potentially understand the last value entered or the return address following a jump instruction. The second technique is analysis, and this can be both static by picking through a non-executing binary and dynamic analysis conducted during runtime. And then the idea here is to try and understand the behavior and potentially identify, interesting parts of the binary. Another option is disk process dumping. In this scenario, a cracker knows the program code and the data that can be found, either fully or partially, in a decompressed or decrypted form, and they'll attempt to grab the code and retrieve usable information from it. And lastly, hackers will try and reconstruct the IAT, the import address table. This can be achieved by tracing the packer and attempting to find out where the actual IAT handling is. Now, assuming the first step was successful, that is, the cracker was able to find and trace the IAT, they can use a tool such as, like I mentioned before, importrec or imprec, or a similar tool to regenerate and reconstruct, even partially, the import table. So SafeNet identifies its current generation envelope as envelope NG, or the next envelope next generation. So the first enhancement of the License Development Kit, or LDK's third generation envelope, it introduces enhanced security protection. This makes the reconstruction of protected binaries from memory dumps virtually impossible. Memory snapshots and dumping are techniques used by crackers, and in some circumstances provide insight into the original application source code. And really, this is exactly where Envelope excels. Envelope makes that process virtually impossible. Secondly, Envelope offers the following advances, and it does this for both 32 and 64-bit engines. The first is what we call import table gating. This refers to how Envelope handles imported functions, meaning any calls that can be imported system functions, and they're redirected via import gates. And this applies to both redirects from the original program and internally from Envelope itself. And we go ahead and implement this for all known system DLLs, and this covers over 3,400 functions. In classic protection wrappers, the import address table allows crackers to distinguish when they are done analyzing each entry in the table. On Sentinel's LDK's third generation envelope, the IAT is not used, and the cracker has no table to enumerate through. Therefore, they will always have uncertainty as to whether they are able to complete a task or not. Envelope uses various techniques to hide imports, such as to make the cracked application fail at a later stage. For example, we fool them by emitting a delayed response. And this renders the expected success totally unusable. Now, in the case of what's called the original entry point, or OEP, the envelope obfuscates the OEP and hides it from inside the envelope code. When protecting an application, the vendor can choose to have the envelope handle constant anti-tracing and anti-debugging. Envelope offers enhanced user mode debugger detection, in addition to detecting whether a debugger is attached to a running process. The envelope offers stronger anti-tracing capabilities as to harden the debugging process. Both these measures are constantly running during code execution, providing various errors and messages as a result, and also using a delayed response that I referred to earlier. And this way it throws the hackers off. And finally, there's the notion of resource integrity protection. And this refers to application-specific information within the PE file, as we previously discussed. It's now protected. And these are, again, such things as menus and logos and icons. And we'll see some of this, or much of this, during our demo. Additionally, the third generation envelope offers the following: a white box-based secure channel between the protected application and the license key. This utilizes the vendor-specific components, ensuring that a secure channel encryption key cannot be extracted from the protected binaries by either using dynamic or static analysis. Envelope now supports what we call user mode software-based licenses. This means that software vendors now have the option of providing a user mode software-based license for Windows platforms that does not require the installation of a runtime environment on the end user's machine. This technique is a unique approach that allows for unmanned installations to take place irrespective of the end user's administrative rights on the target machine. Our approach helps the end user by reducing any delays or additional overhead as they relate to mass deployment. And it does all this without affecting the overall application security. As mentioned early on, malware writers often use packers to hide their malware. And we're aware of the fact that antivirus software sometimes detects enveloped applications as if they were malware. The third generation envelope reduces the amount of AV false positives for those enveloped applications. The SafeNet Software Rights Management team has a very close partnership with the various AV vendors, which results in our binaries being whitelisted on their end. And finally, Envelope now supports a data and file encryption utility. For those of you who are unfamiliar with it, this was previously named the Data Hasp utility for Windows, but now it supports Mac as well. The solution protects files that are accessed by programs protected by the Sentinel Envelope. The data file encryption utility provides a user-friendly interface with a straightforward data encryption workflow that eliminates the need for programming on the software vendor's end. And now we'll switch over to the pseudo demo. As I mentioned before, due to BrightTalk's presentation interface that we're using today, I'm unable to, unfortunately, show you a live demo, but nevertheless, the screens that I'm showing here are unmodified screen captures. Now, I've used I've used four tools for this illustration. I'm going to use PE View, which is a simple freeware viewer for PE files. I'm using a demo version of the IDA Pro, or the interactive disassembler. IDA is a well-known tool for disassembly of various formats, for not only for PE, but for ELF and MACO type formats. Notable about IDA is that it's extensively used by cyber analysts to examine and reverse engineer malware, even those especially packed in packers. I also briefly use the file command within Cygwin, and I've also hooked up IDA to the native Win32 debugger. That's my fourth tool that I'm showing here. So I take the simplest of source files, the venerable Hello World C application. For the purpose of later debugging, I've also had a getch call so that the free running process may be freely paused within the debugger. We know that Envelope uses a binary packer, and by me adding this call and pausing the active debugger on the running process, we know that the code has been successfully unpacked. When I compiled this code in Visual Studio Compiler, I compiled it with no optimization and added fully added debugging symbols. So after building the file, we produce the file hello2.exe, the executable, and run the executable through our Envelope utility. So this is the Envelope GUI. We simply take our hello to exe binary as input and accept all of envelope's defaults. If necessary and or desired, we can modify these defaults. For example, we can decide if we want to disable debugger detection and how often we want to check for a license key in the protection settings. We can also decide, among others, whether or not we want to obfuscate the binary's entry point in the advanced settings. So after we envelope the binary with the default settings, we begin the analysis. Perhaps one of the most fundamental file checking utilities is the file command. Here I've run the file command in the baseline hello2.exe, the unprotected file, shown here up top, and I ran it on the protected executable shown in my second call to file. And even though file tells us that both of these files are 32-bit PE executables, we see file telling us that the debug information is stripped to an external program database, or PDB, for the protected image. So in other words, file doesn't see any embedded debug information and thinks that resides in an external file, even though that file that doesn't exist and whose absence would obviously affect debugging. So now the non-envelope binary is run through the PE viewer static analyzer. So here we see some common elements that identify this as a standard PE file. For example, we see the little endian 5A4D or MZ magic number at the beginning of the file. We also see the legacy MS-DOS stub programs to indicate that this is some type of Windows PE type file. And we see various sections such as the .text file for the read-only executable, the executable code, the RData, the read-only data, the data section for holding global variables, and other sections. And we review the envelope version now of this file. And at first glance, we see a similar structure. For example, we see the PE magic number, that is the 5A4D MZ. We see the MS-DOS stub. However, we no longer observe the standard sections for executable code, data, etc. These sections are renamed to AKS. So even though the section renaming is well within the PE file standard, something has changed as a result of running this file through envelope. Now, if we refer back to the unenveloped, unprotected version of our binary, we see this application's global data section, or .data, and here we see the hello world string in our application. It's important to note that this section does not exist if I were to go back in our envelope version. In other words, we can't even see this string in that file. So we move from PE view and now load the unenveloped binary into the IDA interactive disassembler. When disassembling a module, IDA acts very similar to an operating system module loader. The loader's job, among others, loads the file from the disk, it parses the file header information, and identifies specific entry points in the code. During the loading process, IDA initiates the creation of its own internal database. And contained within this database is a list of every function that IDA recognizes in the file. So for instance here, what I've blown up here is we can see the main function along with printf that's used in our hello when we print hello to our console. Once the binary is loaded, IDA points us to our main entry point, where in fact we can actually see the entire program in assembly that I just wrote. But now contrast this to our envelope binary that we're looking at now. Once the binary is loaded, IDA cannot identify any functions in this application. And our entry point is completely different than the unenveloped binary. But we kind of know that it'll be different because the binary must be unpacked by the envelope loader. So instead of a static analysis, let's take a look at trying to dynamically analyze the executable while it's running. In this case, we'll know that once a binary is unpacked, with the envelope version, we should be able to get a better insight into what's happening. In this screenshot, we're showing the unprotected or unenveloped application. I simply started the application and randomly stopped execution. And if you recall in our simple hello world or hello 2 example, we had a get ch call that basically waits for keyboard input, and it's hanging around waiting for this input at the console. We observe the unenveloped binary, and if we let the debugger free run and then pause this dynamic debug at any time, we'll likely be somewhere within this get ch call structure. And when we look at this, that's exactly where we are. For the unenveloped binary, you'll notice that we're in the anti-DLL.dll, which is a low-level portion of the Windows kernel. Anti-DLL exports the Windows native API, and it's actually on the edge of the kernel itself. So in non-technical terms, we're waiting somewhere within the guts of the operating system for keyboard input. Now let's try and go ahead and execute the envelope version of the binary. Well, we can't. We see an error pop up in Windows. As was mentioned earlier, Envelope has the capability to detect that a debugger is attached to a running process. The Sentinel runtime, working in concert with the protected application, alerts us that we cannot continue our enveloped application because we've attached the debugger. So at this point, we can no longer continue our dynamic debugging process. As I mentioned before, debugging detection, however, is an option presented to you as the software vendor when you're applying the software binary protection to your binary. You also have the option, you have the option to turn this detection off prior to when you're protecting the binary. So let's see what happens if we attempt the same steps, but this time our binary was enveloped without the debugger detection. Well, if you look here, just like the unenveloped binary, we can see that we're in the anti-DLL portion of the Windows kernel with the protected enveloped application. So it's important to note that at this point we can continue to step through the unprotected portion of our code, that is the Windows kernel. However, once we're back in the realm of our code, our hello example, all this will be encrypted and confusing to the cracker. Now switching back to the unenveloped, unprotected binary, as before, we can observe the various functions that are available, and they're visible in the IDA debugger. But again, going back to the protected application, as in the static analysis, this information is not visible in the protected application. So I know this has been a short and simple demo of Envelope, but even though it was simple, I hope that I was able to show some of the anti-software piracy capabilities built into our product, which make it virtually impossible to reverse engineer your binaries. Now, it should be reiterated that while I demonstrated this with a 32-bit .exe file, we could have easily demonstrated this with other PE files such as DLLs, or the same demonstration could have been run on Linux ELF files, for example, and Linux libraries as well. So now I'll turn it over to Asaf to address any questions that may have arisen. Asaf?
Thank you, Mark. So yeah, truly exciting, and really I have to congratulate you on, coming from a non-technical background, you've certainly made me sort of kind of better understand and kind of give me a very good look into how things are done and how kind of impressive sort of these benefits truly are. So I have to you two questions, and I'll start right in. So the first question is basically saying, earlier you spoke about binaries running through Envelope as being whitelisted by antivirus vendors. How can this be done for every binary protected by Envelope? And what happens if my binary shows up as malware?
Well, as I mentioned earlier, we work very closely with the antivirus vendors, McAfee and Symantec and all of them, so now although we cannot assure that every binary won't be flagged by every antivirus utility that's out there. On a rare occasion, if a protected file is flagged, what we'll do is we'll work with those AV vendors to get them whitelisted. So, of course, we'd immediately ask you that you contact our tech support, who will get in touch with those vendors. So but that's very rare. I only hear it, very, very rarely. Maybe once a year, someone may ask a question about it or have an issue.
Okay, sounds good. The second question is basically sort of simply discussing, or I'll just read out the question to make things easier. It's saying, can you explain the level of difficulty to get up and running with the Sentinel Envelope?
Okay, yeah, it's pretty simple. Envelope is installed. I mentioned very briefly what we call the LDK, or the License Development Kit, that actually, as a matter of fact, we just fully announced for widespread release yesterday, but it's been in the field for about a year now. Envelope is installed as a component of what we call our vendor suite. The default installation of this vendor suite is simply point and click. And I briefly showed during the demo for Envelope, by default, you simply put an input file, and then you point to an output file, and you just click protect in the Envelope GUI, and a protected binary is produced shortly thereafter. Now, of course, you can go ahead and fine-tune this. As I showed, you can turn off debugger detection. You can modify, if you need, so you can modify the obfuscation of the original entry point, etc., and that's all available to you. So it's quite flexible, but again, it's point and click from the very start, if you just want to get up and running right away.
Okay, so basically what you're saying is that it has some very, I'm not going to say simple, but sort of straightforward sort of default settings, where which one would basically kind of use unless they wanted to do something more sort of, or less out of the box and sort of more, generic, specific to what they need.
Yeah, and those generic and specific things are not too difficult to implement as well. Like I said, the debugger detection is just simply clicking or unclicking a tick box and to turn that capability on or off.
Okay. We have one last question. And the question goes like this. I'm building rather large binaries, some in the tens of megabytes when done. How long does it take Envelope to protect the binary?
Well, that's sort of a tough question to answer, because it depends on, for example, what type of machine you're running Envelope on. Similar to like when you're building your executable. So it could vary. It could be dependent upon the size of the binary, the composition of binary. For example, if there's a lot of text or data, and the actual, again, the speed of the development machine. Now, off the top of my head, I know I've protected, enveloped applications. As a matter of fact, I think it was just the msql.exe file. I just did that recently, and it was in excess of, I think, around 40 megabytes or so binary. And on a 3 gigahertz Core i7 machine, I think it took me around a minute to go ahead and run that through Envelope. So in other words, for your build process, it's not going to impact it, that much. And so, it's probably the actual the time, the duration that it takes is probably one of the least of your worries.
Okay. So while you were answering that question, we just got in 2 additional questions coming in. The first is, or the fourth is actually, I could say, can processes and threads still be monitored with Task Manager and Resource Monitor?
Well, we'll actually, you can see those. Yes, you will be able to see those in Task Manager or the Procmon. Yes.
Okay. I have an additional, or 2 additional questions actually. The first one is, how do we burn keys that will unlock the envelope of a released application, or if that's even possible?
Burn keys. So basically, a released application, well, basically you take a binary as input, and let's say it's a released application, and you run envelope. And one thing that I didn't mention when you're running envelope, I mentioned how you just take an input file and you take an output file. Well, you also, the whole concept behind our protection is called feature-based licensing. Well, you go ahead and assign a feature to that binary. And so that feature has to exist somewhere within the Sentinel protection system, i.e. it has to exist on a key somewhere for the runtime to access that feature. And so, basically, when you burn a key for a protected application, you want to be assured that it's a personalized key that the application is protected with, that is specific to your vendor information, and also that it contains that feature on that protection key. So basically, the feature is tied to that. The feature number is tied to that protected application.
Okay. I mean, speaking on that whole concept of protection keys, do you maybe want to give some more info, for that specific audience on, sort of the various keys that we have, whether software-based or hardware-based keys? I mean, kind of, the tip of the iceberg, kind of.
Yeah, we have, as you mentioned, we have both HL or hardware keys, and we have SL or software keys, and they sort of dovetail from there. For instance, in the hardware side, we have hardware keys that can be used on a network or not. We also have a built-in real-time clock or not, or a combination of both, so that they can be used locally, on the network, etc. On the software keys, we have that already built into the software keys, and we have this term that we call this marketing term that we call cross-locking, and what we mean by that is that more or less a feature is a feature is a feature. When an application asks for a feature, it doesn't matter where, unless you tell it, it doesn't matter where that feature resides. That is, on the software key, on the hardware key, on the software key on the network, on the hardware key on the network, locally, etc.
Okay. And we have just one last question. It's basically saying, I have a program that links to another program using DLLs. Currently, we read the key from the main ActiveX DLL. Can we use the envelope for this type of application? So I think that potentially, maybe before you answer the question, maybe this one is a more sort of very specific sort of a question. So if you like, either if you think that it will sort of interest the whole crowd, then potentially go ahead and answer. Otherwise, maybe you can take this offline with, that specific person or a specific question. Up to you.
Yeah, that's probably a good idea to have this offline. I could speak in general terms, but without understanding, it's unfortunate that we don't, can't understand the full question here. But what I can do is speak in general terms that yes, we can protect DLLs because it's a PE file, and for example, and not have, we can have an executable that is not protected and a DLL that is protected, or vice versa, and vice versa, as we even seen in the demo, and such that this DLL, if the protected or the unprotected executable needs that DLL, it wouldn't work without the key, and so that can be managed. But again, Asaf, you're right. This is the type of question that probably is best to take offline and work with your sales team and to discuss it. So we can get back to you on that one.
Okay. So I think the easiest would be, I don't know if you have an additional slide basically showing the email address of whom to contact with, either that specific question or any additional questions that were either sort of, put here for everyone, or if somebody has something very specific they want to take offline with one of our sales engineers or with our, one of our salespeople. So hopefully you can show that in your next slide. And Mark and I would like to thank everyone for attending this session today. And this basically concludes our session. So thank you very much again, and see you in our next session. Thank you. Bye.
Thanks.